we need to now show that this is simple harmonic motion, okay, when particle P, it says, is pulled horizontally towards B, okay, a distance of 0.25 meters from C and released. Now remember, to show it's got SHM, we don't, okay, think about it as in terms of it's been pulled the whole distance 0.25 meters, as it says. We think about it as it's on its way to 0.25 meters, okay. So we can say, look, let X be the extension, okay, as it's being pulled 0.25 meters towards B. So it's sort of on its way, yeah? So it's important to sort of consider that so we can set up our equation. We've got a general equation then in terms of X, right? And increasing X. We don't want to have it at the 0.25 on its way. That's our direction then of increasing X. So what we need to do now is we need to obviously appreciate it is moving, so we can use Newton's second law, okay? And we need to appreciate again we've got two sort of tensions going on here, okay? So we've got the tension in the string BP, okay? And we've got the tension in the string, I'll write it up here, AP, okay? And we're going to use Newton's second law, okay? We're also going to look at Hooke's law as well, okay? So let's just start off with Hooke's law here because we need to get this right, okay? So using Hooke's law, let's consider what they will both be in motion. So tension AP. Now let's think about it, right? This is the easier one to do probably. Lambda X over L. So lambda for this will be 15, yeah, for the AP string, it says in the question. Let's think about what the extension will be. Now the extension, of course, well, it's been extended distance X there, yeah? But remember, it's already been extended a little bit there in its equilibrium position, because that's that there, it's C, isn't it, is the equilibrium position. And remember we worked out AC in part A to be 0.5, and the natural length for the spring AP was 0.3, wasn't it? So it already had an extension. If it was 0.3, the natural length, it already had an extension of 0.2 plus then this X, yeah? So it'd be 0.2 plus X. That's what the new extension will be on its way towards B, right? And then over the natural length, which is 0.3, isn't it? So that's AP. Now BP is a little bit more complicated. So the 20 will be the lambda, won't it? Now let's think about BP, okay, from our diagram here. Let's think about the extension. Now, first of all, if AC was 0.5 meters, which we worked out in part A, think about what CB is going to be, right? It's good to actually do that. CB, if you think about it, is 0.9 meters, isn't it? And we didn't state that in part A, but that's what it's going to be, because the overall gap between A and B is 1.4 meters. So that's 0.9 meters. So if it's 0.9 meters, let's think about what the actual extension was of string BP. Okay, well, if you remember, the natural length of BP in the question is 0.6 meters. So that means the extension bit is 0.3. So when it was at C, in equilibrium, when it was at C, the extension of spring BP was 0.3 meters, yeah, because it's 0.9 in total, so 0.3 was the extension. But now, because it's being stretched this way, that extension is going to be cut, okay, if you think about it. So we start off with 0.3, but then we take away the X, whatever X is, because the string is being compressed a bit now, so the extension is going to be reduced. So that's what I'm looking for there, all right? Over then the natural length, which of course was 0.6, okay? So we've got the two tensions there. Now if we use Newton's second law then, in direction of motion, okay, of increasing X, well, we've got the tension in BP, which is going that way. So we've got this here, 20, 0.3 minus X over 0.6. Take away the tension AP, equals then to the mass, okay, of P, which is 7.5, times then the acceleration, which is X double dot. So it's a case then of working this out here, okay? So we'll just multiply these out here. So we've got 20 over 0.6, which is 100 over 3, wasn't it? Times 0.3, which is 10, okay? Then we've got minus 100 over 3x, and then if I work out the next one, got minus 10, and then that will be minus then 50x. Okay, I think I've done that right, equals 7.5x, double dot. Now they cancel, okay, you'll always get that situation occurring, and then we just got to put those x's together. So minus 100 over 3, take away 50, it's minus 250 over 3. So then therefore, then x double dot, but if you divide by 7.5, you get minus 100 over 9x, okay? And that implies SHM, okay? You can say that implies SHM because it's of the form x double dot equals minus omega squared x, okay? Where omega is, of course, the omega squared is equal to 100 over 9, so that implies that omega is 10 over 3, okay, when you square root it, okay? So we've got then, it says, show it's got time period 3 pi over 5, while time period, of course, is 2 pi over omega. So then we've got 2 pi over 10 over 3, which will be 6 pi over 10, which indeed will be 3 pi over 5. Okay, so we've done that.